Good day, my viewers. You are welcome to Understanding Chemistry channel. On today's topic, we're looking at oxidation and reduction. Oxidation and reduction are two opposing yet complementary processes that happen simultaneously. Okay, look at this. Definition of oxidation. You have what about three definitions before when I arrive at that final one, which has to do with what? Which has to do with electron transfer of electrons. Let's look at the first definition. Oxidation was defined as what? Addition of oxygen to a substance. And reduction is what? Removal of oxygen from a substance. Look at reaction of carbon reacting with zinc oxide to form carbon dioxide and zinc metal. So if you look at this, you will see that oxygen has been added to carbon to give carbon dioxide. Then look at this zinc oxide. Oxygen has been removed from it to form zinc metal. So the substance, look at this one. The one that what? Something that donates oxygen. This one donated oxygen to this. So this one is what? Oxidizing agent. Reducing agent is the one that accepts oxygen. Is what? The reducing what? Agent. Or I can say oxidizing agent leads to what? Reduction. Reducing agent leads to what? Oxidation. Okay, let's look at another example. When iron reacts to steam, to give this to liberate hydrogen gas and to give what? Tri-iron tetraoxide. Look at this. Look at this iron. What happens to it? Oxygen has been added to this what? To this iron. So that's what? Addition of oxygen is what? Oxidation. So it means that iron accepted what? Oxygen, isn't it? So remember, the one that leads to oxidation is what? Reducing agent. So what happens to this steam here, water? It means that oxygen has been what? Is removed. You can see from steam to hydrogen gas. What happens? Oxygen has been removed. So that's what? Removal of oxygen is what? Reduction. It's removal of what? Oxygen. So remember, it means that this substance what? Donated what? Oxygen. So that's what? Oxidizing agent. So that's oxidizing agent. So let's look at the second definition of oxidation. So removal of hydrogen is oxidation. What should be reduction? Reduction is what? Addition of hydrogen to substance. Let's look at this example here. Okay, look at this. Hydrogen sulfide reacting with what? Chlorine gas to liberate what? Hydrogen chloride gas and deposition of what? Sulfur. So look at this. What happens here? There's a removal of what? Hydrogen from hydrogen sulfide to give sulfur. So removal of hydrogen from a substance is what? Oxidation. So this is oxidation. So what happened to this chlorine? Hydrogen has been what? Added to chlorine. So addition of hydrogen is what? Reduction. So remember, the one that leads to what? Oxidation is what? That's what? Reducing agent. That species that leads to what? Oxidation. The one that leads to what? Reduction is what? Oxidizing agent. Let's look at the third definition of what? Oxidation. Oxidation is what? Addition of electronegative element and removal of electropositive element from a substance. When you add electronegative element to a substance, that's what? Oxidation. When you remove electropositive element from a substance, that is what? Oxidation. What of reduction? Is the opposite. Removal of electronegative element from a substance is what? Reduction. Addition of electropositive element is what? Reduction. Let's look at this example. Okay, look at the reaction between calcium reacting with chlorine gas to give you calcium chloride. So you can see, yes, metals are what? Electropositive. What do you mean by electropositive? Means they have a tendency to ionize by what? Loss of electron, or by donating electron. Non-metals are what? They are electronegative. It means that they have a tendency to do what? To accept electron. They gain electron, accept electron. So metal is the order, decreasing order of what? Electropositivity. Potassium is more electropositive than what? Sodium, followed by potassium, calcium, magnesium, aluminium, zinc. Okay, look at non-metals. The order of what? Decreasing electronegativity. Fluorine is most electronegative, followed by oxygen, chlorine, sodium, bromine, sulfur, carbon, iodine, phosphorus. So look at this calcium. You know, here you have only one product. What happens here to this calcium? What happens here is that electronegative element, this one is what? Calcium is electropositive. Chlorine is what? Electronegative. So this calcium, what has happened to it here? It means that electronegative element is added to what? Added to calcium. So addition of electronegative element, what does it mean? That is what? Oxidation. So what happens from here? Chlorine. What happens to this chlorine? You have chlorine here, now you're having calcium chloride. What happens is that electropositive element has been added to what? To chlorine. So remember we said that addition of electronegative element, addition of what? Electropositive element is what? Reduction. So remember, the species that leads to what? Reduction. The species that leads to what? Or substance that leads to reduction is what? Oxidizing agent. The one that leads to oxidation is what? Reducing what? Agent. This exercise. This is your bromine gas. And this is hydrogen sulfide gas. To give what? Hydrogen bromide and what? Sulfur. Okay, look at this. I have two electronegative elements here on the right hand side. I have sulfur here, I have bromine gas. When you have two electronegative elements, the most electronegative element among them is going to serve as what? As the oxidizing agent. Let's look at the order of electronegativity. Look at bromine. Bromine is what? More electronegative than what? Sulfur. So the one that is more electronegative will serve as what? Oxidizing agent. So here, this one is my oxidizing agent. Here is what? Reducing agent. Of course, I can also use the terms of addition of hydrogen to also say this one. Okay. Removal of hydrogen is what? Oxidation. Then addition of hydrogen is also what? It's a reduction. The most concise and current what? Definition of what? Oxidation in terms of what? Electron transfer or transfer of electron. Oxidation is a process involving loss of electron, while reduction is a process involving what? Gain of electron. Okay, let's look at this example. So this is your ion 2. In this concept, we're looking at what? Oxidation number. This is ion 2. This is what? Ion 3. You can see there's increase in oxidation number of ion from +2 to +3. What of chlorine gas here? Remember, okay, I did a video on how to calculate oxidation number. That video will help you a lot. If you are having challenges on how to calculate oxidation number, it will help you a lot. So, in that video, we'll talk about that Element in our uncombined state have the rotation number of what? 0. So this chlorine is not combined with any element. The rotation number of chlorine here is what? 0. What about chlorine? This is ion 3 chloride. The rotation number of chlorine in chloride is always what? -1. So here chlorine is what? -1. It means that this ion 2 donated electron and become oxidized to what? Ion 3. And chlorine accepted the electron and become reduced to what? Chloride. Okay, let's look at. You can see the oxidation number of this has changed. This is +2. And it has changed to what? +3. This is oxidation number of ion from +2 what? +3. That species that leads to what? Increase in oxidation number in positive direction. That's what the reducing agent. I think this concept of knowing the oxidation number, electron transfer. If you know this particular no oxidation number, it might not be, because not every time maybe you see oxygen. Okay. Let me use the oxygen added and the electronegative element removed to know it. So this is the easier way for you to know the reducing agent or reducing agent in terms of knowing the oxidation number. Anyone that leads to increase in oxidation number, okay, from +2 to +3, that species is what? The reducing agent. The one that leads to what? Decrease in oxidation number. Chlorine is 0, and here it's -1. 0 is bigger than what? -1. So that one is what? Oxidizing. That species is what? Or that substance is what? The oxidizing agent. Okay, look at this equation. Any equation of this, half equation of this reaction here. You can see ion 2 ion donated 2 electrons and become oxidized to what? Ion 3 ion. Chlorine gas accepted 2 electrons donated by this reducing agent, ion 2 ion, to become reduced to what? Chloride ion. Okay, let's look at another example of zinc reacting with copper 2 sulfate to give zinc sulfate plus copper. What happened here? This is a displacement reaction. Yes. It's also what? A redox, example of redox what? Reaction. Where you have 2 metals, 2 electropositive metal, the most electropositive of them is what? Is the reducing agent. Let's look at oxidation number. If you ask which one is the reducing agent or oxidizing agent, just do your oxidation number calculation. Here, zinc is alone. Oxidation number is what? 0. This copper, if you check it, calculate it, this copper will be what? Copper will be +2. So zinc here is what? +2. Copper here is what? Is alone, so 0. So, like I said, the one that leads to what? Increase in oxidation number. Look at zinc. Look at zinc here. What happens to oxidation number? From 0 to +2, that's increase. That is what? Reducing agent. This one is +2, and here it reduces to what? 0. That's decrease in oxidation number. The one that leads to decrease in oxidation number is what? Oxidizing agent. On zinc, you know that zinc ion is like this. So zinc donated 2 electrons to copper, and copper ion accepted the 2 electrons and become reduced to what? To copper. Let's write half equation for it. Zinc metal, zinc donated 2 electrons and become oxidized to what? Zinc ion. So this is copper 2 -6. So this copper 2 ion accepted 2 electrons. If you want to write electron for this oxidation, this is what? Reduction. So for reduction, place the electron on the left hand side. For oxidation, place the electron on the right hand side. So this zinc accepted 2 electrons from what? The reducing agent and become reduced to what? To copper. So you can see the 2 plus -2, that is 0. There's no charge on this thing. That's 0. 2 plus 2 minus, there's no charge on this, so miss is correct. Because not every equation can be regarded as redox equation. Look at the equation on the board. This equation. Can you call this thing redox equation? Let's look at in any equation where you check the oxidation number of the right hand side and the opposite side, they are the same. That equation is not what a redox equation. Look at the charge on the oxidation number of barium here. Barium ion is what? That's +2. Sulfate ion is what? -2. The what of barium and barium that of a 6. If you check it to give you what? +2. What's the number of okay, let me use better. Let me use sulfur here. The number of sulfur in this radical is what? Is what? +6. If I don't check for sulfur here, I also have what? +6. So this is not the redox equation, because any equation that can be regarded as a redox equation, there must be a change in oxidation number of the reducing agent on the right hand side, and that's what on the product side. There must be what? Change in oxidation number. So look at another one. Look at this equation. You cannot, let's see if this what can be called what? Redox equation. What is the number of sodium here? Is what? +1. The number of oxygen here is also what? Is -2. What is the number of hydrogen here? Is what? +1. What is the number of chlorine here? Is -1. Also, number of sodium here is also +1. Chlorine is also what? -1. Even oxygen here is also what? -2. So you cannot call this thing what? It's not a redox equation, because oxidation number of this element did not change. You stay the same. So in the above equation, chlorine is an oxidizing agent, reducing agent, an electron donor, D, an acid. Let's see which option is correct. What is the oxidation number of chlorine here? Remember, when an element is alone in a combined state, oxidation number is what? 0. So oxidation number of chlorine here is what? 0. Let's look at the oxidation number of chlorine here in potassium chloride. Remember, I told you anything chloride in chloride, the oxidation number of chlorine is always what? -1. Even when you calculate it, to give you what? -1. Remember, reducing agent, there will be an increase in oxidation number of reducing agent. While oxidizing agent, the oxidation number, there will be a decrease in oxidation number of what? Oxidizing agent. Here you have 0 chlorine. On the other side, you have what? -1. So 0 and -1, which one is greater? So it's 0. So 0 is greater than what? -. So there is decrease in oxidation number of chlorine from 0 to what? -1. So which means the answer is what? Oxidizing agent. So always know how to calculate oxidation number, very important. It will help you a lot in identifying oxidizing agent and reducing agent. Come to the end of today's video. My next video, I'll be teaching you how to, I will continue from this topic, how to balance redox equation in acidic solution and basic solution.